Hey, Donovan Keith here, and in this video I want to talk through how to create a random walk spline using scene nodes in Cinema 4D 2024.5. So what is a random walk spline? Why might you want to create one? Well, here's a simple rendering of a random walk spline, and it's sort of at least this version of it, kind of looks a little bit like a lightning bolt, right? We've got a kind of erratic movement from one point in space to another. And let's take a look at what this might look like as it builds up over time. So I'm going to advance one frame at a time. We're sort of, every frame, we are moving a random direction and a random amount. And each subsequent frame, we're sort of increasing the number of steps. Now, I'm manually animating the number of steps in my random walk spline that I've created. But if you wanted, you could create a setup that automatically advances based on the frame number. So we can see that we're getting this sort of interesting pattern that is developing over time, but it doesn't seem to have any clear rhyme or reason to it. I'm going to turn off my Redshift viewport for a moment so you can see that this is really just a spline that I've added a fun material to. And as I advance, we see that it is sort of increasing growth. And then I've just adjusted my seed for the next frame, and it's starting over again. This time, in a completely different sort of random universe, it's now going an all-new set of directions. And what you can do with something like this is, let's say, go over here. You can really crank up the total number of steps that you are taking and create some very interesting-looking patterns. And this is what I'm going to be using to create my thumbnail for this particular video. So how would we go about making something like this? Well, let me walk through this particular setup right here, and let me just increment my save right here, and I'm going to get rid of this animation so you've got a clear sense of what's going on. So on count 0, there are no points. Count 2, we've taken 1 step, 2 steps. Another step, another step, another step. And let me talk through what is actually happening in the construction right here. So the overall premise is I have got the start of a spline. And I'm going to use my doodle tool to sort of paint what's going on here. So I start at a position. And then out of just sort of a complete sort of sphere of possible directions, right? I could go this way, I could go this way, I could go this way, I could go just a little bit this way, right? I pick a random direction that I want to go. And let me just go back. So now I've got a random direction, and I can choose, based on that random direction, how far I want to go in that direction. So that's my step size. And then after I've taken 1 step, I have that same question again. So I'm now in a new place. What direction do I want to go? Do I want to go this way, this way, this way? We're just sort of randomly picking a direction out of a hat, and then we're going that step. And then on the next step after that, you pick a random direction. And you might even end up in a situation where you've actually kind of backtrack, right? That the next step that you take is going back the other way. That's the basic premise. So we are going to, over time, build up an array of point positions where each point position is based on the previous point position plus this random direction, plus this random walk that we're going to do, scaled by a step size. And this is what it looks like in my setup right here. I'm building a simple array of points, so just a single point position at the origin. I am using a range for the number of steps that I want to use. Inside of what's called a loop carried value, which I go into more depth about in another video, which I'll link to, we are generating a random vector, which is going to give us this sort of random direction. We're using normalize to ensure that it is a unit length vector, so it's not going too far in any direction. And then we're scaling this by our random offset, and we're adding it to the previous position. And then we're adding that to our list of points. That random list of points is going to get assembled into a spline, which then gets output. So that's the theory. Let's go ahead and build it together. So go ahead and create a new project file. If you're not already, get into your node's layout. Go ahead and you can hide your console here. We're probably not going to be using it. And what we want to do is add a node spline. So I'm going to hit Shift-C, type nodes spline, drag this out, and now I've got the start of my random walk. The next thing that I want to do is choose to assemble a spline, right? So this is our final output. This is what we want to be building in the end. So let's start there. I'm going to set the mode here to linear, and I'm going to pop the geometry out to the end there. So now we are assembling a spline. Now, assemble spline is expecting an array of points. So I could do something like build array to build an array of points. So maybe use a vector here. And I can output this. So we might even be able to kind of fake a random walk a little bit, right? Just by moving these points around. But this is just a series of random points. They're not necessarily random points based on what the previous point was and walking in a direction. And that's what we want to do. So I'm going to take this build array, and this is going to be the start of my setup. I'm going to truncate this until I only have one point. And this is my starting position. And that's 0, 0, 0 to start. Next, what I want to do is add something called a loop carried value node. So the loop carried value node, it takes a value on the left-hand side. It does some sort of a transformation, and then it outputs it on the right-hand side. And it does that over and over and over again based on this scope input. So every time there's like a little impulse that comes here and says, hey, do that again, it's going to take the thing on the left, do some operation inside, output the value to the right, and then bring that all the way back here to the beginning and do it over and over and over again until we get to the final result at the end that we're going to output. So here, I'm going to rename this vector to cursor. And I like to use a position that I call cursor to sort of track the movement of a dot over time, the movement of this sort of point over time. But we also want to build an array as we're sort of doing this, right? So I'm going to add another input. The type of input 2 here, I'm going to unfold this, and I'm going to turn this into an array of vectors, or a points array. So I click on this far right arrow. I'm going to choose structure. So this is for our data structures. Array is the kind that we want. Right now it's giving me an array of floats, an array of count, sort of like 0.1, 3. I'm going to change it from float 64 by clicking on this down arrow, choosing replace basic vector. So now I've got an array of points, and I'm going to call this, I guess we can just call it points. And I'm going to take my build array. I'm going to pipe it into my points input. I'm going to take the output here. I'm going to pipe it into my output. And I now have the start of my random array that I'm building up over time, this sort of set of random jumps. So I'm going to dive into my loop carried value. And what I want to do is take my points right here, and I want to append a new point, a new position. So I'm going to add an append node, an append elements. The input to this is going to be my points. And what append allows you to do is to take a list of items and add a new item on the end. My cursor here is the sort of position that I'm starting with. So I'm going to take my cursor, and that is now being appended. So every single iteration, every single loop of the loop carried value, we're just going to be sticking the cursor on the end. And right now, we're not outputting anything. So I want to output my points right here. And it's a little bit boring to be using the same point over and over and over again. So what I'm going to do is add. So use my add here, change the type to vector. I'm going to add a position to my cursor every step. And I also want to update the value of cursor every step. So every step, I'm adding a number to my current cursor position. I'm recording that current position in my list of points. And then we're updating the cursor position, and we're updating the list of points of every frame. So if I was to say, this is, I don't know, like 10 by 10, what we're going to get is our initial position, right? Just that starting point, plus this sort of offset that we have set right here. So this plus 10, 10. It's going to append that to our list of elements, updating our list of points, and this now becomes our spline. So interesting enough, but we want to have this happen a bunch of times. And to have something happen over and over again, we need something called the range node. So I'm going to double click, type range, and pull this out. And I'm going to take the output of my range. I'm going to drag it over here into an empty area, and I'm going to choose Add New Input. And the range is just going to count up from 0 to whatever number is here at end, but just a number before that. So this is sort of end before. So if I set this to, I don't know, 20, it's going to go 0, 1, 2, 3, 4, 5, 6, blah, 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 up to 19, and then it's going to end before 20. The next thing I need to do, so right now I'm counting up. You'll notice that there is one of these open brackets with the 3 dots afterwards. This indicates that we are sort of starting a loop. We're about to do a thing a bunch of times. And it is important that we connect this sort of open bracket to a closing bracket variety. These sort of open brackets like this are a little bit dangerous, or the open braces, because they indicate a lot of something is happening. And there's a good chance if you combine these with another one of these and you don't connect these properly, you could get an explosion of points. So we want to be careful. And we're seeing, wow, we sort of do have an explosion of points, right? Our endpoint is at 20. And if I adjust this end value, we are doing this same operation over and over and over again. And if I go to options and show my point indexes, you will see the index of each point as this is happening. So the previous value is being used. We're adding this sort of constant unit to it and moving on from there. So back into our loop carried value, it would be nice if the value that we were adding was not 10, 10, 10, or 0, whatever it is, but a random value. So I am now going to add what is called the hash node. So I'm going to double click, search for hash. And the hash node will give me a random value between minimum and maximum based on the seed and the salt values that I punch in here. So this is a pseudo random, right? We get the same quote unquote random value every time we put in this exact seed and this exact salt. So I'm going to take my hash here and I'm going to plug it into the add. And as I look at this, it's now a lot smaller. If I take a look at my range, I might want to increase the count quite a bit. I'm going to tap H and we see, well, we are getting some amount of randomness, but it's all flowing in exactly the same direction. So we need to influence our randomness in some way with something that is different every single time loop carried value loops through. And that is why this range input is kind of valuable. If this 0, 1, 2, 3, 4, this is the counting number, sort of the index of this given iteration. So that's what I'm actually going to do. I'm going to call this index, index, ... just so I know this is a 0 to something number, and it is increasing or changing every frame. That's why I've added the 3 dots. I'm now going to take my index over here, and I'm going to wire it into what is called the salt value. And that is going to randomize the direction every single step a little bit. But what I'm seeing is it kind of looks like a very optimistic stock ticker, right? It's only going up. It's never going down. So what I want to do is make sure that I can actually go a broader range of values. Right now, we're only going from 0 to 1. But if I type in -1 to 1 on my hash, and I'm going to turn off my, my point indexes, you can now see that we are getting already something that looks and feels like a random walk, right? As we increase our number of points, we get this random walk. And the next thing we might want to do is adjust the size of this random walk. So in my loop carried value, I've got this random value that's coming out. I am going to choose to scale this. And right now it's scaling by 0. So it's just got a length of 0 and it's just kind of disappeared. If I set this to 1, every single step it's moving potentially 1 unit or as much as 1 unit. If I set it to 10, every single step it's moving as much as 10 units. Now if you want to ensure that the step between every single one of these points is the exact same length, but it's just the direction that's changing, we can add a node called normalize. And what normalize will do is it's going to take our, our vector, which is just sort of like a direction in space with a length, and it might say, you know what, I'm going to cap that at a length of 1, right? So, excuse me, there we are. This is the, let's get some color in here. This is the normalized version of this larger arrow. It's the same direction, but the length is being capped at 1 when we normalize. So I'm going to do that, normalize, drag it on this wire. And now it's the movement is a little bit more uniform. It's still random, but each step is the exact same distance. All right. The next thing that I might want to do is to play around with this sort of random universe here, right? So if I adjust this input seed value on my hash, it is changing, but it doesn't seem to be changing that much. In fact, it kind of feels like it's eating the randomness. It doesn't feel like a totally new universe every time, and that's because similar inputs for seed and salt lead to similar outputs. So we want to really spread out the values that are going into the seed and make them a lot more random. So for that, I'm going to add another hash node. I'm going to call this random seed. And for minimum here, I'm just going to type -1 and a bunch of zeros. Hit tab, do the same over here, 1 and a bunch of zeros. And the goal is to basically hit the negative infinity and the maximum infinity that can be stored in an integer value like this. This is what I'm going to punch into my seed right here. And I'm going to take my index value, add that into the salt for my random seed so that we're getting a random number to start, which is being fed into another sort of random number generator, which is giving us a very different random value whenever we manipulate this seed, right? So now it's looking quite different. So the next thing I'm going to want to do is to take this seed value and I want to bring it out. So I'm going to drag it out and choose Add New Input. And now on the outside here, I have the ability to easily adjust these right here. And the next thing I might want to do is take this scale, which is currently set to a scale of 10. I might drag that out. So I'm going to drag this out. I'm going to call this step size. So now I've got a seed value. I've got a step size value. And if I want, I can start adding some user controls for some of these things. So I'm going to double click in here and type IO count. And this is going to be my step count. And that I'm going to plug into the end value for my range. So we can adjust the number of steps. I'm going to add an IO size. I'm going to call this step size. And I'm going to take my seed value, drag this out and choose Add New Input. And now that is seed. So I've got a step count, a step size, and a seed. And I'm just going to adjust a few properties here. So step count, I'm going to right click and choose Edit Port. And let's say a default value of 50 and a maximum of, let's say, 1,000. Or let's say 500. Don't want to go too crazy. And for my step size, let's edit this port. Let's say a default value of 10, step size of 0.1, and a maximum of, let's say, 100. Now the user can play around with this further if they want. And we now have the ability to adjust our step count, our step size, and our seed. Now, as an exercise for you, you might take your random walk spline and start adding in additional features. I, for example, have added an option that will only randomize in X and Y, for example. So I can increase my count, and I've got a nice flat version of this. Or on X and Z, if I want it to only happen in this sort of ground plane. I've got options for my seed, for my step size. And some other interesting things that you might do is once you've got your spline assembled, you might do something like add a trim spline modifier down in here. And you can adjust the length of your spline over time, which allows you to, rather than just sort of snapping as you add new points, it allows you to do it sort of smoothly. You might, if you would like, take your spline and in the Objects Manager, change the type from linear to something like B-spline. And now you've got this sort of rounded curly-Q spline, which might be a little bit more fun to play around with. You could then, if you wanted, add like a luminous material and some glow and redshift and get a nice glowing effect. So here you go. This is our random walk spline. And to quickly review, we are using a symbol spline to make a spline. We're starting with an array that has got a single point at the origin for our starting point. You might even choose to randomize that starting point. We've got a range in order to give us a count of steps that we're going to walk. And then for every single step, we're going into our loop carried value. And we are generating a random seed, which we are using to generate a random direction or a random vector, which is turning into a random direction when we normalize it. We are scaling that direction based on our step size. So this is now a random step. And we are now taking our steps, right? So take step. We are appending each step to our list of elements, append step. And we are updating the position of our cursor as we do this walk. That is the that is the random walk spline and the theory behind how it's created. Thanks so much. And if you make anything fun with this, please post a link. And if you've got any questions, please post those as well. Have a good day. Bye-bye.